Beginning. So, in case you're just tuning in, aka I just turned the recorder on, we've gone through about 10 minutes in this lecture so far. So go read your book. Just kidding. You can come in for help if you want to. But sorry, we skipped it. We forgot to turn the recorder on, and when I say we, I do mean me. So I apologize. So anyway, this is what we're restricting here. And for those of you watching the video to this, what we're doing is we're finding values that we're not allowed to plug in here. And so we analyze each denominator, and we say what value of x would make this denominator equal to 0. So to figure that out, we solved that denominator for 0 and then restricted the values. You'll probably need a better explanation than that, so come see me. All right. This is a good one here. So what should I restrict on this one? Nothing. Yeah, nothing, right? Yeah, careful, right? Yeah, there's no denominator, there's no variable in the denominator. So this is no restrictions, right? Any real number can be plugged in here and we'll never break any rules. So that takes us to just a little Google demo that I wanted to do here. So you remember those little Google things that we were doing yesterday? And if I ask Google to plot y equals x plus 3 and x minus 3, you can see this is just a big parabola. Actually, that could be correct. Yeah, it's just a big parabola with x-intercepts at plus and minus 3. So let's just for fun, and this isn't something you'll be tested on at all. This is just to see what's going on here when we do all this craziness. So let's divide this by something, right? Let's just call it x minus 1. Let's see what that does to our graph. Aha! Let's zoom out a little bit. That makes things super weird, right? First of all, it changes the x-intercepts. Or no, actually, those are the same still. No, you're right. Okay. So the thing that it really does is it creates an undefined value at x plus 1, the value that we would have restricted here, right? And so you can see the graphs, when they reach the x plus 1, or the plus 1 point, they go up into what's called an asymptote, and they never actually reach the point x equals 1. All right, if I go to x equals 1 on this graph and try and find a line that it crosses, it doesn't actually ever cross that, right? And so that creates what's called an asymptote, right? If we slipped that over to, let's say, we called it x plus 3, right? That should shift our asymptote over to x equals negative 3. Uh-oh, that was a bad choice. Hold on, 4. Sorry, that canceled with one of the upper ones. Right, so you can see now the asymptote sort of shifted over. And so it's kind of like whatever binomial we're dividing by, that determines where this weird asymptote pops up. And let's do something even a little bit more weird, and let's divide it by 2 different polynomials, just so you can see what that looks like. We'll divide it by, let's say, x minus 1. All right, things get all sorts of funky. All sorts of weird things happen, right? And this isn't something you'll need to know for this class. It's just, I don't know, it's just interesting to me that dividing by x minus 1 can completely throw your graph into some weird flux. So yeah, that's the Google demo. Mess around with that if you feel like it. Okay. So let's go back to the regular lecture here. So we just learned how to restrict values. Let's now go into simplifying those big rational expressions. So just remember, when we simplify fractions, this is the way it goes. We start with the overall fraction, we factor it into relevant things, right? And then we cancel any matching factors. See, I cancel the 2 8s and I'm left with 3 halves. Well, that's the exact same thing that we're going to do here with all of these rational expressions. So first, we're going to try a monomial over a monomial. You guys are already used to this one. But basically, and let's see now. How should I do this? Yeah, maybe I'll split off the whole factor. So I'm going to do this the long way. This isn't necessarily the way that I'd expect you guys to do this in your homework. You guys are mostly doing this kind of in your head at this point. But if you want to do this the long way, you can rewrite each term into two factors, just like I did with the 24 and the 16 up here. Right? So I can rewrite this as 8x times x. And then I can rewrite my bottom monomial as 8x times 3. Right? And so I just rewrote the fractions just like I do with regular integers. Now all I need to do is cancel my matching factors, and this gives me an x over 3. Okay, so that's how you do that with just two monomials, right? We kind of practiced that already. We already know how to do that one. Sometimes it's not quite like that. Notice how we have a binomial on top here. So if you've got a binomial on top or on the bottom, you want to factor everything you can out to see if you can cancel with anything, right? And so this factorization on the top, all these are divisible by 5, so I'm going to pull a 5 out. So I write my 5 outside of the parentheses, and in the parentheses, I have a plus 3. On the bottom, I have my 10, which actually splits up into 5 times 2. And remember, this whole thing where I'm like splitting off the factors, you don't necessarily need to do this. I'm just kind of taking the long route, just so that we all see what's going on. So now that I notice I have a common factor of 5, I can cancel that. That leaves me with a plus 3 over 2. And so this is a good example just to highlight that you can't cancel over a binomial unless you can factor something out first, right? And so a lot of people are really tempted to just start canceling right away at this step. But unless you can actually factor something out that is multiplied by your binomial, then you can't really cancel, right? So if you can't factor, you can't cancel. That's kind of a general rule. All right. Let's just move up in complexity here. So this one, we have stuff to factor on both the top and the bottom. So in the top, let's see now, I have a 6 and a 12, so I can definitely pull a 6 out. All right, 6x divided by 6 is just x, and 12 divided by 6 is just 2. I do the same thing on the bottom, and I can see here I have a 7 and a 14, right? Those are multiples, so I pull out the 7. 7x divided by 7 would be just x, and 14 divided by 7 would be negative 2. Yeah, then we cancel the x minus 2's, and that's good, because this is a nice satisfying problem. Boom, boom, and we get 6 over 7. Just so you guys know, they do put those frustrating example problems in this book where you like get to the end of your factorization and nothing cancels. And it's like the lamest problem you could ever run into. I hate them so much, but I don't know. They put them in there, so they must have some sort of validity to them.
Basically, they want us to sort of utility.
Yeah, it might be like a lesson in like sometimes these things don't go anywhere, right? Because a lot of times when you're factoring, especially when you get to the higher levels, you're kind of like factoring on speculation. You're just like, if I factor this, will something nice happen? And sometimes nothing nice happens.
That's just, I don't feel good about that.
But when nice things do happen, it can be really satisfying. For some reason, I really like this last step where I get to like cross these out and make a sound effect. Maybe it's just because, right? See, like with this one, it's a little more ugly, and you're thinking, well, that looks like a pain to factor. I'm really hoping something cancels there, but it doesn't always happen. Okay, so for this one, it looks like on the upper polynomial, I have a t in each. Well, I should do my coefficients first. So each of these is divisible by 6. So I'm going to put 6 out front. And then I have a t in each term. So I'm going to put a t out front as well. Good. 3t for the first one, right? Plus 1 on the second. Oops. Plus 1. Now, on the lower one, both are divisible by 3. It looks like that's the highest thing I can pull out, so I'm going to write a 3 out here. And there's a t in each term again, so I'm going to write a t out here as well. Now, what do we have left? Oh, no. Actually, this one isn't too bad. So we have a 2t plus 5 left. Yeah, this one's not too bad. At least the t's cancel on this, right? So now on this one, our binomials don't match, so those just stay here. Our t's match, those can cancel, and then we just have to sort of resolve the 6 over 3, right? 6 over 3 is equal to 2, and then my binomials don't cancel at all, so I just write those out. 3t plus 1 over 2t plus 5. At this point, sometimes people are tempted to try and distribute the 2 back in to do some more work. At this point, you're done. After you've fully factored and canceled some things, nothing really changes by recompiling things and then factoring again.
Where'd you get the plus?
Yeah, I was just wondering now.
Because I put 6t times 3t.
This one right here, you mean?
Yeah.
6t. Yeah, so I took the 6t out of this term. Right? Does that make sense? And so 6t divided by 6t gives me 1. Is that? And you can see that, right, that's got to be the case, especially if, like I say, well, I'm not sure if I factored that correctly. Let me distribute back in and make sure that I got it correct. And I could have gotten it wrong. So 6t times 3t gives me 18t squared. And then 6t times 1 gives me plus 6t. And I say, okay, that matches that. So, okay, whoops, I can be confident now. All right. Oh, and also, you might be very tempted to cancel the 2's here. Be very careful. Yeah, you can't do that, right? If you can't factor it out, you can't cancel it. And since we can't factor a 2 out of these terms, we can't cancel it. We can't cancel just a single 2 in there. All right. So let's keep scrolling here. I'm sure I've got at least one more down here. All right. So this one, you guys know how to factor. Why don't you guys work on your own on this one for a little bit, right? Remember, the steps are you factor the top, you factor the bottom, and then you cancel any like factors. If you guys aren't sure what to do on that bottom, just remember that 1 is a square. Strangely enough, that can be written as x squared minus 1 squared. Not quite. Make sure you get the back first. So this upper part is x back to the lower one. See it? And remember that lower one can be written as x squared minus 1 squared. Difference of squares, right? shell, put two x's in there. Right, say. Well, and you were on the right track if there would have been a bunch of extra terms multiplied in. Yeah. Good. You got your two x's and you say, what factors of 2 adds 3? Bam. You go do it. Nice. All right, so the top factors into, let's see now, x plus 1, x plus 2, and then the bottom factors into x plus 1, x minus 1. Right now we've got two common factors, both the x plus 1s cancel, and then everything else just stays the same. Oh, I always forget to restrict my values at these points in the problems. If I were going to restrict values for this problem, what values would I restrict? And I should note, when you restrict values, you're supposed to restrict them for the initial problem, not the simplification, right? And so, what values would I restrict for this one? Yeah, or minus 1 for that matter. Yeah, we got to look at both those factors and say, if x were equal to plus 1 or minus 1, we would break a bunch of rules here. So we could say x is not equal to plus or minus 1. And this whole restriction thing, it's a little bit, it doesn't seem very consequential right now, but especially when we get into the applications, it can become consequential. And so, like, you know, if you say x can equal plus or minus 1 in the beginning of your problem, and then you solve your problem, and one of your answers is plus 1, you can't use that answer, right? You might have to say there are no solutions to this. So that's where that tends to come in really handy. All right, let's do another one. And, yeah, maybe we'll set you guys loose on this one as well. Give you guys some factoring practice. If you guys are at a complete loss, I'll just kind of build the shell for this first one. Right, it's got to be 3x and x. I think it's mostly the guess and check method, which on something is something like this is actually not a bad way to go, right? Because 3 only breaks up into 3 and 1. That's the only two factors it can be. And a factor of -1, right? One of these has got to be plus 1, one's got to be -1. That's it. So there's really only 2 cases to check. All right, so if you mess around with this long enough, you can figure out that, let's see now, we need a -2 in the middle. So we should have our -1 over here. Because then when we do our FOIL, we end up with 3 times -1 for the outer, and then 1 times x for the inner. Right? And that'll give us that -2x that we wanted. So that's how we factor that upper polynomial. The bottom polynomial is more of a basic one. It's just x and x in our binomials, and they're both negative, right? Because this last term's a positive, but the middle term's a negative, so they both must be negative. And 2 is prime, so we have 2 and 1. So now we just cancel the 1-like factor, x minus 1, and then we leave the other 2 factors there, 3x plus 1 over x minus 2. And I guess I should say, like, you know, when it comes to those denominator restrictions, I'm not too much of a stickler about those. You should definitely keep it in mind. But if you run into like a problem that specifically asks you to restrict those, you definitely do that, because I'll be, you know, I could be a stickler on that. Or if you fail to restrict values in a word problem and then you give me an answer that's not possible, then I might get after you for that a little bit. But in general, like just writing them down on every single problem, it's a good habit to get into, but it's not something that I'll like mark you off on your regular homework assignments. Okay. So there's another sort of situation I want to go over, and I think you guys have seen this through other things before, but suppose we had an example like x minus 1 over x plus 3 times x minus 1. So in a situation like this, you know, even though like we don't necessarily factor anything out because the top matches the bottom, we cancel those. And when we do that, it doesn't equal 0. Be really careful, because this is multiplied by a 1 up here, right? We never cancel out to 0. It just doesn't happen. So this is equal to 1 over the factor we have left, x plus 3, right? And so if you cancel out an entire numerator or an entire denominator, it's not equal to 0, it's equal to 1. Just be careful with that. Alrighty. Opposite factors. Sometimes we'll factor some stuff out, and we'll notice it's not quite in the right. It's not quite the right sign to cancel things, and so we need to factor out a negative term. So on the top, I can't factor out anything on this problem, but on the bottom, I can factor out a 2. When I do that, I end up with 4 minus x. Right? And I notice that these 2 factors are the opposite of what I need to cancel. And so I need to sort of factor a negative term out of one of those. So I'm going to factor a negative out of the bottom. And that's going to leave me with x minus 4 on the top, a -2 factored out on the bottom. And then I swap the signs of everything down there. And so I used to have a negative x, that becomes a positive x. I used to have a positive 4, that becomes a negative 4. And now we can cancel this. Now it's the correct thing to cancel. So I cancel x minus 4, x minus 4. Remember that I had a little 1 on the top. What's that? Yeah, exactly. And the whole thing is negative. Okay. Any questions so far? This stuff, it's not too bad at this part, right? Yeah, the basics are just be careful, factor everything out, and then cancel any like terms. That's roughly, you know, the toughest part about these is just figuring out how to factor everything. All right, let's go into a few extra examples here. And actually, maybe you guys should tackle this first one here. We'll get to the other one in a second. this one, we just want to negative 2 like that. Right, and then you cancel whatever the negative 2 is, we'll leave the rest. Yeah, but what happened, it looks like we canceled the 2 out of the denominator. Perfect. Right, so this should still be negative 8y right here. And then we cancel the 2 with the negative 2 with the negative 8. That's okay. That's what we're all doing. That's what this part of the class is for. Yeah, exactly. Yeah, the negatives disappear. Good. So first, we'll write your denominator there. Oh, so you want to say, okay, I'm going to factor at the top, and then we'll see the cancels with anything on the bottom. So negative 2 and 6, those share factor, right? And so let's pull out negative 2. Right? And so then you say, what happened? Like by the first term by negative 2. Okay. And you just go for what? And you'll find that your negative 2 will cancel with your negative 8 that's in the denominator. Except for, wait, does that say 1? This first one should still be a y. So it should be y minus 3. Good. Okay. And we'll do one more. And I think there's a lot. Yeah. Oh no, that one we don't do. We'll do one more. Yeah. No, the last one I picked that one out of the chapter, and then when I was working it out on my own, I realized it was one of those ones where nothing cancels, and I was like, I can't give that to them at the very end of the class. What a bummer. Yeah. So try this one instead. All right, and remember, all we do is factor the top, factor the bottom, see what cancels. Okay on this one? Yeah, this one's pretty straightforward, right? Not too hard to factor either of these. So for this one, on the top factorization, I set up my normal shell, right? I don't have a coefficient, so it's my normal shell. I have a negative 3, which means one of these is positive and one of these is negative. The positive 2 in the middle, that doesn't say anything right now. So I need to look for two factors of negative 3 that differ by exactly 2, right? 3's prime, so there's not a whole lot of options here. When I add these two things up, I need a positive 2, so I'm going to use a positive 3 and a negative 1. And then down here, I'd be looking for, I have a positive here, which tells me they're both positive or both negative. Then I have a positive middle term, which tells me they're both positive. So I look for two factors of 6 that add to 5. Clearly that's 2 and 3. And that means that we get to cancel one set of factors. Boom, boom, boom. X minus 1 over x plus 2. All right. Any questions? All right. So yeah, that's about it. These really, it seems like you guys are picking these up fairly well. So just remember, don't forget how to restrict values, right? Just make sure we never divide by 0. Besides that, thanks a lot for your patience again, and we're done a little bit early today. So there you go. Go out and enjoy your lives.